This is an example on maxima and minima, trying to find the maximum volume. Few words we have to underline here, which is the rectangular box. And that's like it's a rectangular prism, like a tissue box. Some students might not remember what it means. We have to be cutting square corners of a cardboard. The dimensions, which means the length and the width. And in this case, it's given 16 centimeters by 10 centimeters. Before we start the question, we need to just make a layout of a cardboard, putting the corners as a square. Roughly it would be like that. Having the length and the width given to us, this is the width, which is 10 centimeters, and from there, and the length from there to there, 16 centimeters. By letting the corner that's cut out to be x, and then since they are squares, they would be like that. So if I wanted to write a new expression for the new length, which I mean from here to there, would be 16 minus 2x. And for this part, on this side will be 10 minus 2x. Of course, x representing, in this case, the height of the rectangular box. Now, moving on to the next slide, we can write the length now in the form 16 minus 2x, the width 10 minus 2x, and the height equal to x. As we know, the volume of a rectangular prism is length times width times the height. Therefore, putting all together, it would be 16 minus 2x multiplied by 10 minus 2x times x. So this is our expression for finding the volume. Now v is equal to x, 10 minus 2x, 16 minus 2x. We expand the whole lot. You could expand the first two first. And that, we've done this previously in algebra, so I'm just going to go ahead. For some people wanting to remember how to do this, you multiply each term from the first one by each term, the other next bracket, in this way. So that gives me 160 minus 52x plus 4x squared. We directly just simplified and collected like terms. Again, the next step would be multiplying x by everything on the inside, and you will end up with volume being equal to 160x minus 52x squared plus 4x cubed. Of course, we're after finding the maximum value, and this is what we discussed previously. Finding the maximum or minimum of anything, we need to find the first derivative. So this way we find dv in dv dx, and it gives us 160 minus 104x plus 12x squared. And that's done in the previous lessons on how to find the derivative. Now, to find the maximum volume, we would have to put derivative equal to 0. So dv dx should be equal to 0. From the previous page, we can see that 12x squared minus 104x plus 160 equal to 0. The easiest way to do that is you can divide through by 4, and that would give you 3x squared minus 26x plus 40. The reason we divided, it makes it easier to actually factorize. And factorizing this, whichever method you like, you will end up with something of the form 3x minus 20 into x minus 2, put it equal to 0. Again, as discussed before, when something multiplied two brackets together and gives you 0 at the end, that leads us to one of them equal to 0, one of the other equal to 0. So 3x minus 20 equal to 0, and this would give me x equal to 20 over 3. Again, using two-step equations. From this one, we end up with x equal to 2. Therefore, in this case, we have x equal to 20 over 3 and x equal to 2 over 3. Now, there's a condition here, x equal to 20 over 3. X cannot be equal to that since you have 10 minus 2x should be greater than 0. Therefore, from that we can conclude that x can only be equal to 2 as a solution. We still have to find the second derivative to actually check for maximum or minimum at the point where x equal to 2. So having the first derivative, dv dx equal, back in the previous page, 160 minus 104 x plus 12x squared. Then you find the second derivative, which gives us of course, derivative of a constant is 0, so you end up with minus 104. That's the derivative of 104x plus 24x. So we'll have a look, substitute when x equal to, what happens to the second derivative. So at x equal to, the second derivative is actually equal to minus 104 plus 24 times 2, that is less than 0 if you find it on the calculator. And knowing that the second derivative is less than 0, that means the curve is concave down. Therefore, at x equal 2, we have a maximum. Therefore, the dimensions of the volume that we are looking for will be, going back to substituting for length, it was 16 minus 2x, width was 10 minus 2x, and of course height was equal x. So substituting 2 in each of these, we end up with, therefore the dimensions are will be 12 by 6 by 2, or we could say 12 centimeters by 6 centimeters by 2 centimeters. That's after we substituted the x equal to 2. And this is the dimensions of the rectangular box. Thank you.